Well, hello, mathematicians. Welcome back. Today we're going to be finding a missing term in equivalent ratios. So on the screen in front of you, you see two equivalent ratios. They are 4 to 5 is the same as 12 to something, and 42 to 54 is the same as 7 to something. So how do we find that something? Well, I prefer to stack my ratios so that I can see the relationships right away. And I do it like this. I take a look at the terms that I know. In this case, the first term of each ratio is known. And because I know the first terms, I can find the relationship between them. Right? In order to turn 4 into a 12, mathematically speaking, we multiply by 3. Now, the other thing we could do is divide 12 by 3 to get 4. In either case, we see that the 4 and the 12 are related by a factor of 3. And so we're going to use the same factor of 3 in order to figure out what our missing term is. All right, so in this case, we're going to we're going to multiply the 5 times the 3, and we're going to get 15. And to check it, we'll divide the 15 by 3 in order to see that that in fact is 5. So our ratio then that's equivalent to 4 to 5 is 12 to 15, and we're done. In the second set of equivalent ratios, and by the way, we know they're equivalent because we're told so. There's an equal sign that says, hey, this ratio is the same as the ratio that follows, and they have the same, both the terms have the same relationship, all right? So in this case, we're given a larger ratio, which is 42 to 54, and we're trying to find out what the smaller or more simple equivalent ratio is. It's 7 to something. So in this case, we'll look at the 42 and the 7 and say, what relationship do they have here? 42 divided by what gives us 7? Well, the answer is 6. And if you didn't remember it that way, you may remember the other way, that 7 times 6 is 42. So we see that 7 is related to 42 by a factor of 6, and we're going to use that same factor in order to figure out what our missing term is, right? So we're going to divide 54 by 6 and get 9. And then we're going to check back and say 9 times 6, is that 54? And it sure is. So our missing term here is 9. 42 to 54 is the same as 7 to 9. All right, so now that we understand that what we need to do is look at the set of ratios that we have or we know or are given to us and see what factor they are related by, and then apply that same factor to the missing term, we can understand then how to find any missing term in a pair of equivalent ratios given 3 of the numbers, right? So let's go ahead and give this a whirl. I want you to do these items. It's 13 through 16. Go ahead, pause the video, and come back to me. Do the work, come back to me. Well, hopefully this is what you have. You can see in item 13 that 6 is related to 30 by a factor of 5. 6 times 5 is 30. So we're going to multiply the 7 times 5 and get 35, and that's our missing term. In item 14, this is the first one we've done where the first ratio in the equivalent ratio is missing. And so we have to look to the second set, that's the 42 and the 6, and see how they're related. Well, we know they're related by a factor of 7. So we'll apply this factor of 7 here to 28, divide 28 by 7 and get 4. So our missing term is 4. In item 15, we also have a situation where the first term is missing, and we're going to look at the relationship between 64 and 8. we see that 8 times 8 is 64. So something times 8 is going to give us 48, and that something is 6, which is our missing term. And in item 16, you see that 4 times 9 gives you 36, and 9 times 9 gives you 81, which is our missing term. Did you get them right? I hope so. Well, let's go and see how we can make this apply in a real world situation. We have students in a school musical, and they're going to sell tickets. Each student is expected to sell 3 youth tickets and 5 adult tickets. The students use a table to predict how many tickets will be sold. How many tickets will be sold if 50 students sell tickets? Okay, so our understanding of this is that for every one student, there are going to be a certain number of youth and adult tickets sold, right? So one student's going to sell 3 youth and 5 adult, right? So for every 3 youth tickets, there are 5 adult tickets. That's a 3-to-5 ratio. Well, if 2 students sell tickets, then we're just going to multiply this each term by 2, right? And we're going to get not just 3 youth tickets, but 3 times 2 youth tickets sold, and that's going to be 6. And for adult tickets, not just 5 adult tickets, but 5 times 2, which is going to give us 10. What about if there are 3 students? What then? Well, if you said you're going to multiply 3 times 3 and get 9, and 5 times 3 and get 15, you are absolutely correct. This is how our ratios are going to increase as we go along. Well, this is what the table looks like. And you see, in fact, we're right. At every stage, we're going to have a simplified ratio of 3-to-5. And we're just multiplying this by the number of students as we go along to figure out what the number of tickets, total numbers of tickets sold is, right? So for 4 students, that's going to be 4 times 3, which gives us 12. And 4 times 5, which gives us 20, right? All right. Well, what if 50 students sell tickets? We take our ratio of 3-to-5 and we simply multiply each term by 50. All right? So 3 50s are 150 and 5 50s are 250. And this becomes the answer to our table here. That 150 youth tickets and 250 adult tickets would be sold, which is 400 tickets altogether. Now, you do have to realize that this will completely fall apart since each student is expected to sell this many. What happens if they don't? What happens if nobody decides to sell anything or everybody sells more? Then they will need more or less, fewer or greater number of tickets at the time that they put on this musical. All right. Got to keep the real world situations in mind. Well, you see another chart in front of you now that the student council is selling bouquets. And we know that the bouquets are daisies and tulips, right? The ratio of the number of daisies to the number of tulips, this is daisies to tulips, is the same for all bouquets, right? And we see that the only one that's given to us is the second row here that we have 24 to 12 is the number of daisies to the number of tulips, and that's 2 bouquets. So how then do we figure out 1 bouquet? Well, if you think about it, hopefully you said to yourself, just divide them by 2. So we have 24 to 12 here in our second row. If we divide each of these terms by 2, then we should have the number for 1 bouquet. And 24 divided by 2 is 12, and 12 divided by 2 is 6. So indeed, for 1 bouquet, you have 12 daisies and 6 tulips. Not a very nice 6, but such as it is, that's 6 tulips. All right. So I just want you to notice that for every 2 daisies, there is 1 tulip. And this ratio is true for every row, right? 12 to 6, rather, is a ratio of 2 to 1. And 24 to 12 is also a ratio of 2 to 1. If you divide 12 by 12, you get 1. And 24 by 12, you get 2. If you divide 6 by 6, you get 1. And if you divide 12 by 6, you get 2. So 2 to 1 is the ratio for every row. And if we continue that ratio into the third row, we should be able to see how many daisies are going to be in a bouquet if there are 18 tulips, all right? So looking at this pattern, there are a few ways to solve this for this missing piece. We can say, well, 1 bouquet is 12 to 6. So 3 bouquets is going to be these numbers times 3, right? And that would be 36 to 18. And that checks out, right? Because we have 18 here, and so right here we have 36. Now the question is that still a ratio of 2 to 1? Well, if you divide 18 by 18, you get 1. And if you divide 36 by 18, you get 2, because 18 plus 18 is 36. Or 18 times 2 is 36. So yes, that checks out. And you have finished your chart. All right. Well, now you have a couple of problems to do. Numbers 17 and 18. I want you to do them both. Pause the video and work both of these. This is on pages 136 and 137 in your textbook. And once you get them done, come back to me. Okay, so here are the answers for number 17. I just want to point out that the ratio is going to be expressed, and I've color-coded it for you, in a specific order: Selena's earnings to Drew's earnings. And you have that in this ratio right here, right? 31 to 33. And so the fastest way to do it, or the most logical way to me, was to set up that ratio 31 to 33 up at the top here, and then multiply out, because we were asked for 4 days and 30 days for both Selena and Drew. So multiply them each term by 4 and then each term by 30, and that would get our answers. And that's what I did. So there you see that one. So let's look at the last problem. And this is just completing the chart for number 18. I'll give you a chance to look that over. The key here now, I just want to point out that to get you started, you were not given any ratio that had both values filled. So this is the first one where you had to kind of extrapolate the information in order to see, what was your ratio in simplest form, right? So I thought that the easiest way to do that, at least for me, you may have had a different way, was to go ahead and use this 14,000, realizing that that's 2 tons, and divide 14,000 by half, or by 2 rather, to get 7,000 per recycled ton, and then multiply those out, which will give you your next 2 answers. And in each case, the ratio of the amount of oil saved to the amount of water saved was 19 to 350. And I think that's it, right? All right, that's all I have for you. See you again soon.